Okay, hello everyone, good afternoon. Am I audible?
Yes, sir.
Okay, so in the last lab, I think assignment 6 was going on. How many questions you had finished in the last lab from assignment 6? Is it finished? Yes. Okay, how many questions you have completed? Yes, from assignment uh, up to the 5. Okay, yeah, all of you have done it up to the 5. That is a fifth questions. All of you have done it up to the 5. Okay, okay, good. So let's complete the remaining questions. Question number 6, 7, 8, and here we had two more questions related to the dual graph, chromatin number, and so on. Okay. So here in this question number 6, it is similar to the 4 and 5. In this question 4, uh, we have one of the graph which is a non-planar, and we apply the embedding procedure to make the graph planar. Okay. And then after we can verify the Euler's formula, that is n minus e plus f, that is equal to the 2. Okay, so that is verifications for Euler formula. We check number of vertex, edges, and number of faces. Then answer of n minus e plus f, you will get a 2 always if the graph is a planar. Okay, so that we apply in the 4 and after in the 5 also. Okay, and now we can also apply this similar criteria to the question number 6, but here some graph are non-planar. Okay, embedding is not possible in Peterson graph, then after in K34 and in K6. Clear? So which argument will consider in such type of graph where the graph is a non-planar? Okay, so you can draw the Peterson graph here. Okay, that is if it is required you can draw it the shape of Peterson graph. Clear? uh, 5 and 5 vertex are the inside, make one star by using that one and connect the corresponding vertex. Okay, so that is shape of Peterson graph. Clear? The first one. And here in this answer, okay, here the Peterson graph, okay, as we checked during the lecture session also, the Peterson graph is a non-planar graph. Okay, it is a non-planar graph. Clear? Why it is non-planar? Because embedding is not possible to the Peterson graph. We cannot draw this graph without cross over the edge. Okay, there are 5 edges are crossed inside the graph, and here it is not possible to make such graph without crossover. So embedding is not possible in planar Peterson graph. Therefore, it is a non-planar graph, and thus we cannot verify. Means Euler formula cannot be verified. Okay, Euler's formula cannot be verified. Okay, we cannot verify. So it is answer of Peterson graph. Clear? If it is a planar, then we can easily verify the Euler's formula. If it is non-planar, then it is not possible to find answer of n minus e plus f is equal to 2. Okay, so that is answer of first one. And now in the second part, there is a K34 is given that. Okay, so same argument you can write in this K34 graph. Clear? As we discussed in this lecture session, okay, we have one of the base. Okay, that is a K33, and as we know that K33 is a non-planar graph. Okay, we already verified that is a Kurosawa's second graph. Clear? So K33 is non-planar. So K34 involve more vertex as well as more edges comparison to the K33. Okay. So also K33 will be non-planar. Okay. So K34 graph is a non-planar graph. Okay. It is a non-planar graph. Okay. Thus, Euler formula cannot be verified. You can also draw the graph here. Okay. Euler's formula. Just draw the picture of K34 graph. Cannot be verified. Clear? That is answer for K34. Okay. And now second is a K23 is given that. Clear? So in K23 we can easily embed that is the actual shape of K23. Okay. That is a graph of K23. And now embedding is possible in K23. Clear? So here it is the embedded graph. And now this graph look like a planar. Clear? That is look like a planar. How many faces are that? 1, 2 are the inside and 3 is the outside. Okay, 3 faces. Vertex are 5, edges are 6. So Euler's formula, that is n minus e plus f, for this graph, that will be verified. Okay, so there is a 5 vertex, 6 edges plus 3 faces. So that you will get a 2 answer. Okay, and that is a verified. Is it clear? Is there any confusion in this answer? Yes, have you any doubt? Clear? Now complete this both the question and now write the answer for K4 and K6. Clear? In this K4, you can easily embed the K4 graph. Clear? So Euler formula will verified in K4. And in K6, write the same argument here. A K6 is a non-planar graph because we have the base graph, that is a K5, which is a non-planar. So after the K5, okay, every complete graph after the K5, that always will be non-planar graph. Okay, so here it is a K6. So K6 is a non-planar graph, therefore Euler formula cannot be verified. Okay, so complete the question number 6 and do it also the K4 and K6. And reply in chat box when you finished. Okay, then we'll start 7 and 8. Yes, all of you have done it. Question 6. All of you have finished both the question. Let's see. Aditya, Gopal, Kalpana. Okay. So now let's start question number 7. That we already discussed, means already done in the lecture session. That is one of the corollary. It will be the connected planar graph, uh, which is a simple graph also. Okay. And number of vertex, which should be greater than equal to 3, with number of edges and f be the number of face. When edges is equal to the edges should be less than or equal to 3n minus 6. Okay, that we already proved in the lecture session. So let's discuss it again. And based on this theory, we can solve the question number 8. Okay. Okay. So just notation are changed. Here we consider V notation as a vertex form, and here in this PPT we consider N notation. Okay, so there is no any difference. So G be the connected simple planar graph with N vertex, E edges, and F be the number of edges. Then how many vertex? How many edges is required to define such graph? Okay, means what is it boundary? How many edges up to the how many edges we can consider to make such connected planar simple graph. Okay, simple graph means no any loop, no any parallel edges. It should be connected and it should be planar also. Okay, so up to the how many edges we can take, that is here e less than or equal to 3n minus 6. Clear? Then we can say it is a connected simple planar graph. Clear? So proof is given already. You just write down one by one line. Clear? G be the simple connected planar graph with n vertices, E edges, and n be the number of faces. And here this condition we consider directly here, that you can verify for any of the planar graph 2 times of E greater than equal to 3f. And from this condition make f as a subject. So f will be 2e divided by 3. Okay. And we have this is a Euler graph. Okay. So it will satisfy the Euler's formula. Clear? So what is Euler formula? N minus E plus F is equal to 2, and make F as a subject from this formula. Okay. So F is equal to minus N plus E plus 2. And now replace this F to this equation. Okay. So it will become minus N plus E plus 2 less than or equal to 2E by 3. Okay. And simplify that. Minus N plus 2 as it is here. Okay. And E will be shifted this side. So it is a 2E divided by 3 minus E. Okay. And now simplify that side. So it is minus n plus 2 less than or equal to that you will get a minus e by 3. Okay. 2e minus 3 divided by 3. So it will be minus e by 3. And now apply negative sign both sides. Okay. So it is n minus 2 greater than equal to e by 3. Okay. The inequality will be changed. And that your required answer e less than or equal to 3n minus 6. Okay. 3 multiplied to n minus 2. So it will become e less than or equal to 3n minus. Okay, so that is a proof of this one. Complete it, and then we'll start question number 8. Yeah, that is already given in this PDF file. Okay, so you can write it later on. Okay, whenever you're free. So let's start question number 8 also. Clear? So we can finish this assignment in today's lab. In this question number 8, okay. Okay, we use these conditions to check which of the following graph is a planar. Okay, we use these conditions. What is the use of this condition? If we create a planar graph by taking 4 vertex, okay, आप एक planar graph बना रहे हो by taking 4 vertex, So how many ages you can consider up to the how many ages, okay? Means what should be the boundary of number of ages where your graph is a simple connected planar graph, okay? So that will be 4 vertex you have. So what the answer? That is a 3 of 4 minus 6 and that is a 12 minus 6 is equal to the 6, okay? So you can take up to the 6 ages to make such graph. Okay, we can take up to the 6 edges to make such connected simple planar graph by taking 4 vertex. Okay, so if this graph contain this range, okay, the graph number of edges should be in this range, okay, should be in this boundary, clear, up to this boundary, then this graph is a planar. If it is greater than this boundary edge, okay, greater than 6 edges for this 4 vertex graph, then it is known a non-planar graph. Okay, so here in this first case, we have the K5 graph, clear? And we'll check the K5 is a non-planar by using this formula. Okay, so how many vertex in K5? 5 vertex, and how many edges that we know? Okay, there are 10 edges. Okay, and we know that this graph is a non-planar graph. Okay, we apply the embedding procedure to that graph and we get the result. It is a non-planar graph. Okay, but let's verify by using this formula. Okay, how many edges should be there to say it is a planar? Okay, so here, as per the formula, the number of edges will be 3n minus 6, and 3n minus 6 means 3 of 5 minus 6, and that is equal to 9. So how many edges should be there for 5 vertex graph to say it is a planar? That is up to the 9 edges should be there. Okay, that is one limit for number of edges. अगर उसमें 9 edges है, okay, up to the 9 edges है, then this graph is a planar. Okay, if it is contain more than 9 edges, okay, if the graph contain more than 9 edges, then the graph will be non-planar graph. Okay, so here how many edges are there? There are 10 edges. When we count number of edges in K5 graph, there are 10 edges. Clear? So that is greater than 9. Okay, so for to say it is a planar, up to the 9 edges should be there. Okay, less than or equal to 9. But यहाँ पे तो 10 edges है, ठीक है? So what does it mean? Okay, that is graph is a non-planar graph. Okay, this graph is a non-planar graph. Is it clear? Yes, is there any confusion? Okay. Now second example, K4. Clear? So as we know that K4 is a planar. Okay. So here that formula will match the answer also. Okay. So K4 is a planar graph where 4 vertex are there, 6 edges. Clear when we count. Now as per the formula, we'll verify that it is a planar or not. Okay. So here the formula is a 3n minus 6, and how many vertex are there? 4 vertex. So it is a 3 of 4 minus 6, and 3 of 4 minus 6 is equal to 6. Okay, means how many edges should be there to say it is a planar? The graph should contain up to the 6 edges. Graph should contain up to the 6 edges, then this graph will call planar graph. If it contain more than 6 edges, then it is called non-planar graph. Okay, so how many edges are in the K4? When we count it, how many edges are there? There are 6 edges, clear, and that is up to the 6 edges. Okay, that is in the range, clear. So we can say that graph is a planar. Okay, if we, for example, if we have here 7 edges, clear, for such case it will be the non-planar. Okay, so now it is a planar, clear. And here we get one quadratic result also in K33. Okay, so that we'll discuss at last. Now let us discuss the K13 graph. Okay, so K13, there is also 4 vertex K13 shape. Okay, and how many edges in K13? It is simple graph, 1 vertex opposite 3 vertex and connect it, clear. That is called K13 graph. Okay, it is a planar connected simple graph. Okay, and how many edges are there? 3 edges, clear. And as per the formula, how many edges should be there? Clear. If it is up to the 3n minus 6, then it is called planar. Okay, so let's check how many edges should be there. So 3n minus 6 means 3 of 4 minus 6, and that is equal to 6, means up to the 6 edges should be there. Okay, then it is called the planar. So how many edges are there? That is only 3 edges. So we can easily make such connected planar graph without crossover. Okay, and that is also simple graph here, clear. So K13 is a planar graph as per the formula. Okay, as per the rule. Is it clear for K13 graph? Is there any confusion in this all the three case to anyone? Okay. Now in the last one, here we get a contradict answer here. Okay. And therefore we consider the one result here and the last line. Okay. This is a necessary condition, not a sufficient condition. Okay. So why we consider it here? Because here we get contradict result. Okay. As we know that K33 graph. Okay. With 6 vertex and 9 edges. This graph is a non-planar graph. Okay. That we verified many times during the lecture. Okay. This graph is a non-planar graph. Okay. How many edges are that? 9 edges, 6 vertex. Clear? So let's verify by using this formula. Is it a non-planar or not? Okay. So as per the formula, that is edges should be less than or equal to 3n minus 6. And what is the n here? 6 vertex. So it is a 3 of 6 minus 6. Okay. And that will be 6 into 3, 12. 6 into 3, 18 minus 6. And 18 minus 6 is equal to 12. Means up to the how many edges are that? There are up to the, it should be the 12 edges. Clear? Then we can say is a non-planar graph. Okay. Graph by taking 6 vertex, it is a non-planar graph. But here it is, how many edges are that? That is only 9 edges. Okay, the graph contain only 9 edges. So as per the formula, it should be the planar. Okay, it should be the planar. But here we check that we already verified that it is a Kurosawa's second graph, and that is a non-planar graph. We cannot embed this graph as a planar form. Clear? So therefore we get a contradict result. What is a contradiction here? कि ग्राफ में 6 वर्टेक्स के लिए 12 एज एटलीस्ट होनी चाहिए. ठीक है, इट शुड बी द अप टू द 12 एजेस. इट शुड बी अप टू द 12 एजेस टू से द ग्राफ इज अ प्लानर. बट यहाँ पे तो ओनली 9 एजेस है. इट शुड बी द प्लानर. बट हियर द एक्चुअल रीजन इज एक्चुअल conclusion is it is a non-planar. So therefore we get a contradict answer. Okay, here in this all the first three graph. Okay, in this K5 that is satisfied here. Up to the 9 edges should be there और यहाँ पे 10 edge. ठीक है, so therefore it is non-planar. Here it is up to the 6 edges and here the 6 edges are there, so it is a planar. Okay, here it is also same, up to the 6 edges should be there and here it is only 3, so it is a planar. Okay, and here it is up to the 12 edges should be there and here it is only 9. Okay, that is less than 12. Still the graph is a non-planar as per the verification. Okay, so therefore it is a contradict and therefore we can write one reason here. Okay, this condition, okay, it is necessary condition only. It is not sufficient conditions for all such graph. Is it clear the solution of question number 8? Is there any confusion in all these four answers? Just check it again. If you have still any doubt, particularly in K33, okay, that is one contradict answer here, and remaining all this example it's verified. Okay, but in K33 it is not verified. Does all of you have any query? Okay, so now just take the screenshot of this answer. Okay, and whenever you free, complete in your book. Clear? In assignment book, just take the screenshot of this four answer. Question it is also given here. Okay, just take the screenshot of this answer and complete in your lecture board whenever you free. Okay, good. Now let's start question number 8, 9, 9, 10, 11. Okay, that is not given in the assignment, but we had here for more practice in last two topic of the unit number 6. Okay, that was the dual graph theory and the graph coloring concept. Okay, that given as an exercise in this PPT. Okay, I just consider this question of exercise in this assignment. Clear? That is given as exercise in PPT. But let's solve it in the assignment, so you'll get some practice. Okay, for this two topic. So question number 9, find the dual graph of the following. Okay. So just read the dual graph theory if it is required. Okay. And then after you can make the dual graph of all this one. And solution are already available in this lecture note. Okay. You can also match your answer with that. Simple step you have to follow first. The first your graph should be the planar to make a dual graph. Okay. Second step, we just put one vertex inside to the each region. Okay. Of this given graph. Clear? Also consider exterior region. Clear? Place one vertex to the each region. That is 1, 2, 3, and 4. Okay. And then after check adjacency relations of each region. Okay. And then after connect these two particular vertices which they are adjacent. Okay. By cross this adjacent edges. So first check inside shape. Okay. Inside the graph. Here 1 and 2 are adjacent by this edge. So cross this edge and connect it. Okay. 1 and 2. 1 and 2 are also adjacent by the below edge. So cross this edge and connect 1 and 2. Clear? 2 and 3 are adjacent by this edge. So cross it and connect 2 and 3. Clear? Now do it for exterior region also. Okay. So 1 is adjacent by this left hand side edge with the 4. So connect 1 and 4, cross this edge. Okay. Similarly, 2 with 4. It is adjacent with the below edge. 2 with 4 adjacent with the above edge. Clear? So connect it. 1 with 3 with 4. It is adjacent with this below edge. And 1 with 4 adjacent with this above edge. Okay. So cross it and connect 3 and 4. Clear? It is a dual graph of this one. Clear? And you can also verify it. Okay, is it correct or not? Okay. So check the adjacency of exterior place. Clear? Okay, how many edges are at the boundary of the given graph? There are 5 edges. Okay. Are at the boundary of this graph. So what should be the degree of this exterior vertex? It should be the 5. Okay. So that is graph of dual graph of the given one. That is for your practice. Okay. Complete it and draw in the your assignment book. Okay. So that is question of dual graph. Is there any confusion to anyone? Okay. Just take the screenshot of this graph. Okay. Question 9, 10, 11. Because that is not given in the assignment file. Okay. Just I add as an extra question. Okay. Just take the screenshot of this 9, 10, 11. That is question number 11. Okay. Now let's start question number 10. In that you have to check the chromatic number of the following graph. Okay. Chromatic number means how many minimum color is required. How many minimum color is required for vertex coloring of that graph. Okay. So let's solve the first one and rest of you can practice. Clear? X of G. X of G is denoted a chromatic number. If you read the theory of chromatic number, that is a definition of chromatic number. Okay. The minimum number of color required for vertex coloring of the graph G is called as the chromatic number of the G. Okay. Denoted by X of G. Clear? So here in this graph, X of G will be. So let's put a first color to that vertex. Okay. That is not a vertex name. That is a color number. Okay. Let's assign the first color to that vertex. So I cannot put a first color, means color number 1 to that 3 vertex because they are adjacent. Okay. So let's assign the second color in this graph. Second color to that vertex. Okay. So this vertex is connected with 1 and 2 both. Clear? So I cannot use the 1 color and 2 color to that vertex. Clear? So we'll take the third color in this picture. Clear? I assign the third number color to that vertex. Clear? Now this place, it is not adjacent with the 2. So I can put second number color here. Okay. And this one it is not adjacent with the 1. So I can put 1 number color. And here I can put a color number 3. Okay. So how many color is required for that graph? 3 color. Okay. So what is it chromatic number? X of G is equal to 3. Okay. Is it clear how to check the chromatic number? Yes. All of you have any doubt in the vertex coloring? Yes. Have you any confusion? Anand, Ovia, Neville, Parthiv. Okay. Now do it for second graph right now, and rest of it's for your practice. What is answer for second graph? Just write and reply answer in chat box. How many minimum color is required? Yes. What is the answer in second one? How many color is required for the second graph? 2 color. Yeah, very good. Okay. All of you have got the 2 answer. Okay, nice. Clear. So rest of you can practice it. Clear. First graph, second one, that is second graph. Third, that is this one. Fourth, it is Peterson graph. And 5 and 6. Consider one of the complete graph, K5. Okay. And 6, consider one of the complete bipartite graph. Okay. So practice it for this type of graph also, where it is a fixed answer. Okay. K5 may be fixed answer or K23 may be fixed answer. For any of the complete graph, answer is a fix. Clear? So also practice it for K5 and K23 also. Okay. Now last question of this syllabus of this assignment is question number 11. Apply the region coloring. Okay. So for regional coloring, the graph should be the planar. Okay. Graph planar hoje. And then after you can assign the minimum number of vertex such that no to any adjacent region should have the same color. Okay. In this chromatic number, in this vertex coloring, we just check no to any adjacent vertex should have same color. Here we just check no to any adjacent region should have the same color. Okay. So let's solve the first one, and second and third you can practice. Okay. So let's assign the first number color to the inside the region. Okay. I put color number 1 to that plus. It may be any color. Okay. One number means any color you can use it. Clear? And here I can put a 2. Clear? Because they are adjacent. Okay. Now this place is adjacent with 1 and 2 both. So I will assign the third color. Clear? And here I can put a 2 because 2 is not adjacent with this place. And 1 and 2 are adjacent. Here I can put a 3. Clear? And here 1, 2, 3 are adjacent with this 3 with this region. So here we consider the fourth number color to this picture, okay, to this graph. So 4 color are required to the inside. Now rest of the graph, 1, 2. Here I can put a 1, okay. Now 1, 2, 3 are adjacent with this plus, so here I can put a fourth number color. And 2, 3, 4 are adjacent with this plus, so here I can put a 1, okay. 1, 2, 3 adjacent with this region, so here I can put a 4. And here it is a 1, 3, 4 is adjacent with this plus, so here I can put a 2. Clear? So what is the answer? Chromatic number of that graph is equal to the 4. Okay, 4 color is required for region coloring. You just check all the side. Okay, બધી side check કરવાની છે કે no two any adjacent region should have the same color. Clear? This 1 means one color. Okay, 2 means second color, 3 means third color. Okay, and so on. And just 1 minute. Clear? So rest of you can practice. That is last unit, last question was the assignment. Clear? And before 2 days I already create link for the submission of assignment 3. Okay, so up to this Saturday, clear, you have to submit the assignment 3 also in the Google Classroom. Okay, clear. So now take this screenshot of this slide if it is required. Okay, this question are not given in this assignment. Clear? So you just add it in your assignment 4, assignment 6, sorry. Okay, 9, 10 and 11. Clear? So up to this Saturday you have to submit the assignment 6. Clear? In this Google class. Is it clear? Okay, so is there any confusion to anyone? Okay, good. Okay, so we'll start the next assignment, assignment number 1 from the next lab. Clear? So all of you finished all this assignment of graph theory. Clear? 4, 5, 6 if it is remaining, and revise all the topic whenever you free. Clear? Because graph theory part is now finished. Will not any of the concept of graph theory in assignment 1, 2, 3. Okay, so revise all the topic again whenever you free. Practice it for writing also. Okay, and check all the definitions, identified counter example, solve, revise this assignment. Clear? Whenever you free, clear each and every questions. Clear? So let's finish this lab. First we'll take attendance and then into today's lab. If you have any doubt, any query, you can ask.